Hi, everyone. Welcome to Socomec's webinar on the advantages of power quality meters in industrial facilities. We're thrilled you've joined us today to discuss this topic. Today, we will explore how continuous power quality monitoring can help detect and address issues like voltage fluctuations, harmonics, and power interruptions, preventing disruptions and equipment damage. Please stay for the entire webinar for a chance to win a free product sample of Socomec's newest A200 power quality meter. Any questions you have will be answered at the end of the webinar, so feel free to add them in the Q&A box throughout the webinar. I now want to introduce our host and expert for today, Thomas Leonard. For the past 7 years, Thomas has served as the Power Monitoring Global Product Manager, where he played a pivotal role in shaping the direction and success of Socomec's power monitoring solutions. Currently, he is the business developer for North America, focusing on expanding the reach and impact of Socomec's innovative technologies across the region. Please join me in welcoming Thomas.
Hello, everyone, and thank you, Rachel. Thanks, everyone, for joining us today for this webinar on power quality in industrial facilities. We have a fair number of people. We have people from North America. I see we have people from overseas as well. So I know it's late. Thanks for joining. So we're going to start this webinar. Just a quick intro. We're going to talk about power quality and power quality issues in electrical installations. And I think it's important to understand that power quality issues can and disturbances can come both from the utility, external to the electrical installation, but they can also come from your own distribution from the loads. So when you're within an electrical installation, your own facility, you may experience disturbances from your own installation, but they can come from the utility, from the grid, but also from your neighbors. So if you have your neighbors are negligent in monitoring their power quality and making sure that their network is not polluted, well, you may also experience those issues in your own electrical distribution. So let's take a look at the agenda for today. We're going to start talking about the power quality issues that you can have, examples of external issues that are coming from the grid, from the utility, or your facility's neighbors. Then we will focus on the types of disturbances that can be internal to your own facility. And then we'll look at how power quality meters can help, how to select the right power quality meter, where to install it. And then we'll look at what Socomec has to offer. We recently launched new power quality meters in the past few months. So we'll take a look at the different features that they offer and how they can help you address those disturbances in electrical installations. We're going to start this webinar by a quick poll that should be popping up on your screen shortly. So we're going to wait a few seconds to let you answer this poll. Right. I think we can close it now. So we'll use some of the results. So let's see. So it's interesting. So we're seeing, you should be able to see my screen. We're seeing rarely and sometimes as being the highest choices. So that's converting, and that shows that this webinar is well suited. A few nevers, but mostly rarely and sometimes, which is consistent with what I've heard in the past and That makes sense. I think power quality issues and events are increasing, especially with the addition of electronics and EV charging, etc. Those types of equipment. So thanks for voting. Thanks for answering. We'll close it now. All right. So I just wanted to introduce, before going into the types of disturbances that we can find in electrical installations, I wanted to introduce the IEEE 1159 standard, which is more of a, it's almost a handbook. It's really, it provides power quality guidelines for users, and it really focuses on the types of disturbances that you can have in your electrical installation. It talks about both external disturbances and internal, which is the main difference with some of the European standards. So it's looking both at events coming from the utility and events that can originate from your own facility. It talks about the effects that those disturbances can have on equipment. It talks about the types of measurement devices that can be used and that can be considered in detecting, monitoring those types of events. It talks about the types of electrical parameters that are worth monitoring. We can see some of those on the screen. And it talks about the benefits of implementing power quality meters and monitoring devices. So it's we can focus, and that's what we're going to do in this presentation. We're going to focus on a few of those disturbances, a few of these events, such as voltage variations, harmonics, unbalance. That's what we're going to look at today. But there's a lot more parameters that can be measured, that can be monitored for site operators, for facilities managers to understand what's going on within their electrical installation. So I highly recommend the 1159 handbook standard, which is really good, almost like a technical note, a guideline to understand power quality in electrical installations. So let's talk about the examples of disturbances that we can find external to the electrical installation. We're going to talk about voltage sags. We're going to talk about voltage swells, and interruptions. Quick definition: a voltage sag is a reduction of the voltage at a value that is between 90 and 5% of the nominal voltage. When we're talking about these events, whether it's a sag, a swell, or an interruption, we're talking about all phases. We're not talking about one of the three phases. It's all phases simultaneously. That's a sag. A swell is a peak. We call it also a surge, a spike, but it's a peak value that exceeds 110% of your nominal voltage or reference voltage. And interruptions is a reduction in voltage of a value under 5%. So it's below 5% of the reference voltage, nominal voltage. So it's below the threshold for a sag. So here we're assuming that, we're looking at possible external power quality events that are coming from outside of the facility. These voltage variations, all three of them, they're considered short duration RMS variations, even though there's different classifications. You can find momentary, you can find long duration or short duration for all three of these events, depending on the duration. If it's lasting a few cycles, if it's lasting a few seconds, and then over 1 minute, it's considered a long duration voltage variation. But we're considering these to be examples for external power quality events, even though they can actually originate from your own facility. For example, a voltage sag can be triggered by a fault on the utility network, but it can also originate from a large inrush because of a large load start, like a motor start, for example. Typically, a voltage sag will result in high current draw and can cause overheating and motor damage. Some of the voltage sags will also disrupt industrial and control processes and can cause tripping of equipment such as VFDs, etc. Voltage swells and also interruptions, all three of these types of events are typically associated with what we call system or utility fault conditions. The swells are much less common than the sags. They're also caused by switching on or off large loads, which can come from your own facility, that can come from a neighboring plant, and they will cause equipment degradation, premature aging, also tripping of equipment, and then interruptions, which are also caused by faults on the utility network, some automatic fault clearance. As I said before, the interruptions will be usually preceded by a sag, depending on the duration. And again, they can cause process shutdown, damage of electronic equipment, especially when voltage is interrupted and then there's an abrupt recovery of voltage. So those need to be monitored, documented. Obviously, when you're creating reports, this can be used as a proof to your utility, because usually the maximum number of events that are allowed should be given in the service agreement with the local power provider. So if they're exceeding these number of events, this is something that should be documented. You should find proof, and this is where we're going to see how power quality meters can help do that. Now we're going to focus a little bit more on the disturbances that are internal to the facility. This is what you have more control over. And that's why I'm going a little bit faster on the events that are external, because you're undergoing those events, you're passive to those events. The ones internal to your facility can be anticipated if there's the proper monitoring solutions implemented. The first one is we're going to look at harmonics. Just a quick definition in case everybody's not familiar with harmonics. But harmonics, it's part of the electrical signal whose frequency is a multiple of 60 hertz. So usually in an electrical installation, the ideal would be to have 60 hertz signal only, but you have a mix of multiple of the frequency, so 120, 180, etc. And this mix of harmonics will distort this, the sinusoidal waveform. Harmonics are generated by what we call non-linear loads, such as power electronics, VFDs, arc furnaces, and more recently with converters such as EV chargers, energy storage systems. So those are the types of equipment that will draw current that is distorted current because of harmonics. It's interesting to look at and to understand the propagation of harmonics within the electrical installation. And we can look at this in different steps. The step one is that's your voltage supply, and ideally it's a sine wave. It's a clean sine wave free of harmonics. But then within your electrical installations, you may have linear and nonlinear loads. Your nonlinear loads, such as VFDs, for example, for motors, will create a distorted current waveform. But this current will flow through the system impedance, so the source, the line impedances, the cables, and this will cause harmonic voltage that will actually distort the voltage supply. So that's what we're seeing in number 3. If you look at the harmonics, the voltage harmonics at the point of common coupling, it could be distorted because of the current harmonics more downstream in the electrical installation. So due to voltage harmonics, even the loads that are linear, that are not causing a distorted current, might receive a distorted voltage. So you may see some distorted currents and distorted waveform with pollution on linear loads. So that's what I was explaining. Because of grid and transformer impedance, even if you have, if you have a neighboring facility, a neighboring plant that has high voltage harmonics, even if your own facility only has linear loads, you might actually experience some high voltage harmonics because of the grid and the transformer impedance. So current harmonics generated by a neighbor could actually find its way and generate voltage harmonics upstream. And this voltage harmonics is what is going to be used by all the loads in other parts of the distribution. So there's some guidelines. There's a standard that is the IEEE 519 that defines voltage distortion limits for low voltage, medium voltage, and high voltage systems. It typically defines at the point of common coupling, so for voltages below 1,000 volts, so low voltage installations, it typically defines a maximum total harmonics distortion of 8%. So that's what, both utilities and customers are supposed to respect, is making sure that the total harmonic distortion at the point of common coupling doesn't exceed 8%. Some utilities will incorporate the IEEE 519 guidelines into their service agreement. So they may ask that customers comply with these harmonics, these maximum limits to maintain power quality. There's even some regions where the utility might charge penalties in case of excessive harmonics pollution. So even though the IEEE 519 is not mandatory per se, some utilities might charge penalties because of excessive harmonic current, and because it could cause damage to the transformer. It might require the utility to oversize the transformer and to use a transformer with a higher K factor. So they might charge not only a penalty for damages, but also a cost for potentially replacing some distribution equipment if they find out that the harmonics content originating from your facility is too high. And the impacts of high harmonics in electrical installations: overheated transformers, reduced efficiency of transformers, overheated motors. So, harmonics will increase the RMS value, the peak values. So nuisance tripping as well. Depending on the harmonics order, you may have some overloaded neutral. For example, if it's harmonics, the third harmonic, for example, will accumulate in the neutral, and which will, for all the phases, it will accumulate in the neutral. So this will create an overloaded neutral, so overheating of the neutral conductor, which may have to be oversized. And it'll also disrupt some control and process control devices. Just a few facts. As an example, when the THD on voltage on the supply exceeds 10% or reaches 10%, the service life duration of the equipment, if we're talking about a three-phase motor, for example, is estimated to be reduced at 18%. So that's for harmonics, which is a very common phenomenon in electrical installations, especially nowadays that we have more electronics, VFDs, etc. Now let's talk about current imbalance, another very common electrical power issue for industrial plants. What is imbalance? Imbalance is an uneven distribution of, you can talk about current imbalance or voltage imbalance. So it's an uneven distribution of voltage or current among the phases. So that causes a difference in amplitude or phase angle. So that we can see typically if you have a three-phase system, and if your current for phase one is higher than phase two and phase three, you're going to have current imbalance. So when we talk about imbalance, we're really talking about the origin is really current imbalance. That's what originates from inside the facility. Power providers typically keep voltage imbalance below 1% or below 2% maximum. So it's not common to have a voltage imbalance that's caused by the utility, the power provider. But current imbalance usually comes from when you have a mix of single phase, two phase, three phase loads, and their uneven distribution within the, across phases. That can happen also when you have loads that are switched on and off. So if you have single phase loads, for example, that are all on phase one, that's going to create a current imbalance. If some loads are switching off, that may create imbalance on the other phases. If you have a faulty contactor, a loose connection, or a phase loss because of a blown fuse, for example, that's also going to create some imbalance on current. But that current imbalance will also result in voltage imbalance upstream. And depending on the load level, the current level, that upstream voltage imbalance can become pretty high and can actually have a backfeeding effect on the rest of the electrical installation. So the upstream and voltage imbalance can propagate throughout the distribution, and typically a voltage imbalance will magnify the current imbalance by usually 5 or 10 times higher levels. So that upstream voltage imbalance will have consequences on the rest of the distribution and create additional current imbalance. An imbalance will cause VFDs to trip. It will cause premature aging, potential damage to motors, vibration, overheating, degradation of insulation, and inefficiency, overconsumption of equipment, such as motors, for example. There's an interesting table that gives the effect of imbalance on motors, and we can see that just a 2% voltage imbalance will result in an 8% temperature rise. And according to NEMA standards for electrical motors, every 10 degrees Celsius increase in temperature increase reduces the life expectancy of the motor by 50%. So we looked at harmonics, we looked at imbalance. Another one we can look at, which is linked to imbalance somehow, but it's phase losses. So when we talk about a phase loss, we're talking about the complete loss or absence of one or more phases in a polyphase circuit. We're not talking about all phases altogether, or that would be a sag or an interruption. We're talking about one of the phases in a polyphase circuit. So a phase loss can be caused by a blown fuse, a faulty contactor or a breaker, loose or poor electrical connections at terminals, and phase loss can happen at different levels within the electrical installation. And there's different consequences, whether we're looking at the upstream or the downstream installation. Typically, an upstream consequence will be that if you have a phase loss downstream, your current and your voltage will be unbalanced at the large three-phase feeder level. And the downstream consequence, for example, it could be that if you're losing a phase upstream, all your single phase loads that are connected to this phase will be interrupted. And phase loss will create VFD tripping and, in general, poor operating conditions on three-phase machines that are being supplied by that faulty circuit. So all motors, pumps, compressors operating on this three-phase circuit that is experiencing a phase loss might malfunction and experience reduced performance and potential failure over time. So we didn't look at all the power quality disturbances and events, of course. We looked at the main ones that we're most familiar with and that are easy to monitor. Let's look at how power quality meters can help. Well, the first easy solution is when you're installing a power quality meter on the main incoming feed of the electrical installation, is you're monitoring a variety of voltage parameters. That's, for example, harmonics, imbalance, or you're monitoring the quality of the incoming power from the power provider. It's important to understand that the power quality meter is not actively going to solve power quality issues. It's a tool to detect disturbances, to help locate the origin of a disturbance, to understand and analyze the cause, to be able to take the proper remedial actions, such as, we're talking about adding harmonics filters, UPSs, surge suppressors, upgrading to a higher K rating transformer, for example. So it's really a tool to help take the right decisions based on the investigation. So monitoring the supply, making sure that the power quality, the power provider, sorry, is meeting the service agreement, making sure that the quality that he's supplying is good to your facility. The fact that power quality meters can log measurements over time, they can be recorded, so you can use that as a proof to your power provider if they're not meeting their service agreement. Power quality meters will detect events such as sag, swells, interruptions. So you keep, those are logged, they're time-stamped, so you can have a report, you can build a report, and you can include more details such as waveform capture, such as amplitude, such as duration, and you can show that to the power provider, saying that they did not respect the service agreement. But then, when you're installing power quality meters, it's important to understand, and we'll talk about that in the next slide, but the more granular and the more downstream you're going and you're installing PQ meters, the more you're going to be able to understand where the events are coming from. Is it an event coming from the grid, or is it something that's because of a load condition on my own installation? So being able to isolate between external events and internal events. And doing load monitoring, individual equipment monitoring will really allow you to understand the impact of your nonlinear loads on your installation. Do they have an impact on other equipment within your installation? Do they have an impact upstream? Are they being fed back into the utility, and could they have consequences for your neighbors? So make sure you're avoiding penalties and you're not responsible for upstream equipment failure. And of course, when you have a power quality meter, the goal is to be alerted when there's, bad operating conditions. So the goal is to warn site operators, facilities managers, that there's deviations in the measurements that's causing bad operating conditions, so a higher imbalance, for example, phase loss, to alert and to take corrective actions before they create too much stress and potentially cause damage if that's not already too late. So where do we install power quality meters? The easy answer is to say, yes, we're installing a power quality meter on the main feed to make sure that, as I was saying, that the utility is providing good quality power and is meeting the standards or guidelines recommendations. In Europe, EN 5160 is mandatory for utilities to follow. So they in the service agreement, they must respect the standard, and they must not exceed a certain number of events, sags, swells, interruptions. They must also stay under harmonics maximum limits below 8% THD. So the power quality meter on the main feed will allow to make sure that the utility is following the service agreement. But then as you go downstream, you want to determine if the origin of the power quality, the bad power quality, is internal or external. So implementing different power quality meters at strategic locations within the facility, being able to compare measurements downstream versus the point of common coupling will help identify which area or group of loads the pollution is coming from. And doing so, you might be able to correlate measurements. Looking at voltage upstream and current downstream, you may be able to correlate measurements for a better investigation and understanding. And then downstream, monitoring individual circuits or individual equipment, for example, a motor, that will allow you to understand if the operating conditions of your equipment. You will be able to correlate, again, the measurements of the downstream equipment with upstream. So for example, if the upstream power quality meter is detecting a voltage sag, can you correlate that with the start of a motor, high inrush current? If that's the case, the voltage sag is not going to be coming from external. It's not going to be coming from the utility. It's not external. It's within your own installation. So permanent versus portable analyzers. We're always recommending to install permanent power quality meters. That's the preferred type of products. Portable analyzers will give you a good analysis, but it's usually a short duration period. It's usually a one-shot analysis for 1 week or 1 month, but it's not really an analysis that's carried out over a long period of time, over 1 year or 2 years. To be able to determine the origin of the disturbance, you're usually required to have different PQ meters in different locations. So just one, whether it's a portable or one permanent power quality meter, might not be sufficient. And the big advantage of permanent power quality meters is that they can be used for other purposes than just power quality analysis. All power quality meters, of course, monitor consumption, demand, and other parameters that help with energy management initiatives. So when you typically install a power quality meter on your main feed, you also have your demand profiles, your consumption, that allow you to understand how your facility is consuming energy. It allows you to identify ways to avoid peak demand charges. It allows you to size the distribution correctly. Do you know if you can add more load to the distribution, to the existing distribution, without doing some upgrades? So a power quality meter can have a much bigger purpose than just analyzing the cause and consequences of disruption, of disturbances. But typically it could be a mix. A good practice is to mix and to use together permanent power quality meters and power monitoring devices with portable analyzers for a finer root cause identification. It's not realistic to be able to implement power quality meters on every single circuit within the distribution. So a good practice will be to focus on, of course, the main incoming feed, then the major sub feeds or the major critical loads. And then if there's additional analysis needed, then you can rely on portable analyzers for that. So let's look at what Socomec has to offer in terms of power quality meters. We very recently launched our new Darce 200, which is a power quality meter. It's very universal, which meaning it can operate with all the different service types of North America, whether we're talking about 277, 480 volts, Y, Delta, 347, 600 volt networks in Canada, whether we're talking about 240 volts, 120, 208. It's compatible with all service type with the same product. So it's the same product will handle all service types. It can actually measure up to 1,000 volts. So there's some certain applications with higher voltages. Well, the A200 will measure voltage up to 1,039 volts line to line. The meter comes with power quality monitoring functions. So it'll monitor harmonics, it'll monitor imbalance, power factor, K factor. So it's really a variety of parameters that are well known at this point. All of these parameters are measured, they're stored internally to the meter. We can actually record a 1-year log of measurements with a 15-minute reading interval. So a data point every 15 minutes will be stored in the meter for a year. You can change the reading interval, you can increase it to 1 hour, and in this case, we'll store the measurements for up to 4 years. All these measurements that we're talking about, harmonics, unbalance, power factor, the meter can have a custom alarms thresholds created. So if you want to be alerted as soon as a threshold is exceeded, as soon as there's a high value, a deviation, that's something that the power quality meter, the A200 can do. It comes with native communication, standard communication, RS-45, Modbus RTU. It comes with Ethernet, dual Ethernet, Modbus TCP, and Modbus and BACnet IP for easy integration to most of your SCADA systems, EMS or BMS software. The A200 has a free built-in web interface that allows to measure to visualize all the measured parameters. So everything that I mentioned before, including volts, amps, demand, and consumption parameters can be visualized remotely on a free web interface. There's no subscription, there's no license. The A200 comes with the free web interface. It allows you to visualize real-time parameters. So if you want to look at, operating conditions at a given time on a machine or a circuit, you can do that, but it also stores measurements, and you can go back in time and visualize your historical measurements for free. A200 also has some native input-outputs, digital inputs, 3 and 1 digital output, which we'll talk about a little later. And for power quality events such as sags, swells, interruptions that we talked about, the A200 will initiate an automatic waveform capture during the event. So it'll capture the event, it'll store the waveform, and on the web interface, you're able to visualize the waveform during the event. So that's something that can be used as a proof to the utility when you have, a summary of alarms, of active and past alarms with details such as duration, such as amplitude, such as the waveform capture. That really serves as a proof when you're going back to the power provider. So that's about the A200. It's made in our facility in Denver, Colorado, and we can actually provide it either as a standalone panel mount product or in a factory wired enclosure, NEMA 4X enclosure that can be mounted for retrofit right next to your electrical panel, your switchboard, your motor control center, anything you're monitoring really. So we have the two approaches. Either it's designed and it's built into the panel, or it can be used as retrofit. Just a few words on the WebView S interface that I was talking about. So again, it's a free interface, and you have different menus allowing to view real-time parameters of all types. Then you have an alarms and events menu, which allows you to take a look at active alarms, and also a log of a summary and a log of all the finished alarms with the details such as waveform capture, as I was saying. We have a scope mode, which allows you to view the real-time waveform. So you go on a piece of equipment, you want to see how distorted your signal is, you can connect and look at the scope mode for this equipment. Again, we have the trends menu, which is a trends and consumptions menu, which are historical measurements for kilowatt hours and all the different electrical parameters. Everything is stored in the power quality meter, the A200, for up to 1 year with a 15-minute reading interval. And all these measurements can be exported in a CSV spreadsheet. Okay, we're gonna do another poll, second poll. So there should be a poll coming up on your screen shortly. There it is. So, we talked about malfunctions. The question, how it's good to monitor power quality and disturbances, but it's even more important to be notified quickly when there's a disturbance or a deviation in operating conditions. So that way you can be notified before malfunction occurs. So pick your preferred method of notification in case of a disturbance, and we'll take a look at the results. All right, it's pretty even. 46% say email, 67% say text message. That's interesting. Panel screen notification, 29%, and remote monitoring software, 31%. Okay, that's pretty even, but the text message is seems to be the preferred method. So there's different ways that the A200 will notify you of an anomaly. The first and most obvious way is locally on its screen. So we have an alarm LED that will be red or flashing red, depending on the severity of the event. You can go in the alarms menu to really understand what the event is about, when it occurred, the duration, the values, things like that. So that's really a local way to see the event. It's you see it on a panel door. You're inside the facility. You see the meter flashing, for example. Then we have the web interface, of course, WebUS, which will display the alarm and the active alarms and the log of the finished alarms. So you have everything that is accessible with the timestamp, the duration, the origin of the alarm, the amplitude. For power quality events, you have the waveform capture accessible. So that's something that we have in the web interface, the WebUS. Then emails and texts. So those are notifications that you're getting on your phone. So we do have the email functionality that the A200 can do. You can set up an SMTP server, and you will receive an email describing the type of alarm, the type of event, and a little bit more details. So you're notified in real time. So that way you can take corrective actions. I actually found out 2 weeks ago that there's free services to convert an email into a text. Most cell phone provider, whether it's Verizon, AT&T, T-Mobile, you can use all of them using a 10-digit mobile number, followed by, in the example of AT&T, for example, you do your 10-digit mobile number at text.att.net, and instead of sending a text, it'll send an email, or vice versa. But so for those of you who prefer text over emails, that's totally possible. Another way to be notified is using the A200's digital outputs. So we have a digital output that can be used to report an alarm. So any alarm that you configure on, for example, a high imbalance threshold or high harmonics, an overvoltage or SAG, any alarm on a condition can be reported into the A200's digital output. So when the alarm activates, the contact will open or close, and this contact can be used. It can be integrated and connected to a PLC, for example, so integrated to a larger ecosystem or monitoring software. You can use those digital outputs to connect it to a relay, a contactor to perform a switch off operation to really protect the load in case of an abnormal condition before it's damaged. But you can also use the digital output to power an LED on the panel, for example, or to sound an audible alarm, things like that. So that's another way to be notified. So there's numerous ways. It's very flexible, depending if you want to be alerted locally or remotely, and if you want additional integration to your system. All the alarms are also accessible through Modbus communication. So if you want to be just reading Modbus registers through communications, that's also possible. An exclusive technology that we have with the A200 when it's connected to our ITR current sensors is that we're able to sense voltage on the individual conductors. So the ITR current sensors are, of course, monitoring current. They're current sensors, or CTs. But we also have a smart electrode inside that's sensing the presence or the absence of voltage. So we're capable of detecting not only if the protective device is open or closed, but also on individual poles to identify if there's a potential phase loss or a fault in the protective device, like a faulty contactor, for example. Because we're monitoring current and voltage, and because you can put it upstream and downstream, and because the A200 will both measure voltage and detect the presence or absence of voltage, we can actually determine if the phase loss is upstream or downstream in the distribution. And all of these conditions, whether it's an opening, a trip, a blown fuse, that can be alerted through the different methods that we talked about before. The screen, the communication, the email, text alerts. So if you've made it this far to this webinar, you have a shot at winning a free sample. We actually have 3 free samples available. So we're going to have a random draw, and we're going to pick 3 names. We're not going to do it now. We're going to look at who participated, who subscribed, and who participated and made it all the way through the webinar. And you'll be getting an email shortly if you won the free kit. So the kit comprises an A200 power quality meter and also 3 TF200 rope style current sensors that can measure from a wide measurement range from 12 all the way up to 4,800 amps. So you'll be getting an email from us shortly if you've been selected, and we'll ask for your contact information and shipping address. But that's the end of this webinar. So thank you so much for joining. There will be a recorded if you want to watch it again. If you have questions about, we couldn't address everything today, but if you have questions about what we introduced with the different disturbances, if you have questions about the features of the A200, if you want to get a free demo of the web interface, feel free to reach out. You have my email address here. You can find a lot more information about the A200 if you want to if you want to scan the QR code on the screen. You'll find a lot more documentation, brochures, installation manual, con tables, pretty much everything related to the A200. So we're going to look at questions now, but thank you so much. All right, let's see if I can. All right. Some reason I'm having trouble. No, here it is. All right. Okay. Will we be able to have a copy of the presentation? Yes, there will be a copy of the presentation as a PowerPoint, and there will also be a recording that will be made available in the on the SOCOMEC website. Yes, this another questions about the slides of the presentation. Yes, this will be made available. If you want if you want the slides, just shoot me an email. You have my email address here. If you want to send me an email, that way I'll respond with the slides. I think that'll be easier and that will be quicker. There's another question. Does your power quality meter measure K factor? Yes, the A200 does measure K factor. So that's another pollution indicator for harmonics. So it does measure K factor, and depending on the value, it allows to properly size the transformer and select the right K factor rating. Is the IEEE standard mandatory? I think I briefly talked about this. It's technically not mandatory, but there are certain utilities that will integrate it to their service agreement, and that will almost make it mandatory. The local regulations will not look at it as a mandatory standard. It's more of a, best practice and recommendations for your own factory, your own equipment. But you have to look at your own power provider and see what the service agreement says, because sometimes they will make those maximum thresholds for a THD mandatory. How many power quality events does the A200 store? So by power quality event, we're talking sags, swells, interruptions. The A200 will store 100 sets of power quality events, and 100 sets. A set is 7 waveforms. So you have, say, 4 currents and 3 voltages. So that's 1 set, and the A200 will store 100 sets, and then it's a first in, first out. But you can extract those as you go. You can have an extract of all these past events through the web interface. Is installing the quality meter closer to the equipment downstream recommended? Yes, it is. If you want to understand, if you want to monitor that equipment specifically, if you want to make sure that the equipment is operating under good conditions, which means a low imbalance, that's typically what you're going to want to do. If you want to make sure that this equipment is not generating too many harmonics, that's also what you're going to want to do. But at the same time, it's important to have several power quality meters installed throughout the facility, not to individual loads, maybe sensitive loads, and also power quality meters upstream to understand if, for example, you have an equipment downstream like a motor, or if the VFD, for example, that's generating harmonics. Okay, it's generating harmonics at the load level, but what impact does it have on the rest of the distribution? Does it have an impact upstream, and does it have impacts elsewhere on other loads? And that's what I was talking about on the propagation of the harmonics pollution. So it's really to be able to investigate on the origin, the location, and the impact of harmonics pollution. Yes, installing power quality meters and multiple power quality meters closer to the load is recommended. How much is the highest sampling frequency of the Darius meter during events? So we're doing 160 samples per cycle, and that actually can be configured in the meter. You can have a longer recording of multiple cycles, pre-recording, post-recording, or pre-event, post-event, and the maximum sampling rate, which is configurable, is 160 samples per cycle at 60 hertz. Is there training possibility for installation and setting the web view? Yes, we have a service and tech team here in Boston which can provide some training services on how to configure the meter, how to use WebView, the best practices for installation, things like that. So we do have those services. Yes. How many sensors? There's a question about the number of sensors on the A200. The A200 has 4 sensor inputs. So you can monitor all 3 phases and have a dedicated sensor for the neutral conductor. How is the device powered? So the A200 is powered from 110 to 600 volts. So it has a separate power supply connector, which can accept any voltage from 110 to 600 volts direct. So no need for a control power or step down transformer to power the meter. It's rated for all service types for voltage measurement and power supply. Is Rope CTs the same as Rogowski CT? Yeah, the Rogowski is the technology. So we do have Rogowski CTs that can connect to the A200. They're great because they're rope style. They're more flexible. They can measure high currents, so they're great for bus bars, for example. They're great for monitoring thousands of amps. They're much lighter. They're much easier to install for bus bars, for cable bundles also. So they're a lot more flexible for than rigid type CTs, whether they're solid core and split core. So yes, rope style Rogowski. Will there be an enclosed version of the A200? Yes, there is an enclosed version available for the A200. So as I said, there's the standalone version, which you can mount on the panel door directly, or you can design inside a panel. But there's also the enclosed version, which is going to be used for existing facilities, existing installations for retrofit. Does the device work effectively with 50 hertz appliances? Yes, it's both compatible with 50 hertz and 60 hertz systems. So that gets configured in when you're doing the programming. You set up the nominal frequency. .600 volt delta, yes. Yes, it's possible. I don't know how common it is, but yes, it can handle 600 volt delta. The A200 is rated 600 volts phase to neutral. And yeah, 690 volts phase to phase. What is the max voltage? So per UL, and that is really a UL limitation, but per UL, they could only test the A200 up to 690 volts line to line. Per IEC, the meter will measure voltages up to and is rated up to 1,039 volts. So at the moment, per UL, it's limited to 600 volts line to neutral, 690 volts line to line. What is the highest order of harmonics that the device detects? We can measure up to the 63rd harmonics. There's still a lot of questions. I don't know if we'll be able to answer all the questions, but if I haven't answered your question, feel free to send me an email. Answer this. Yes, somebody asking about the visibility of the power quality monitoring in real time. So that's typically, I mean, on the web interface, you have access to all those parameters, harmonics, and balance, the waveform in real time. So if you have an A200 on a single piece of equipment, for example, you can look at load conditions in real time. And then with the storage of data, you can go back in time and understand the evolution over time. Some of the industries that we're selling to, so not limited to, but the main industries we're selling to are data center, commercial facilities, industrial facilities would be the three main markets, I would say. In terms of industries itself, we have car manufacturing plants, we have pharmaceutical plants, we have bottling companies that we sell to, we have tire manufacturers, we have machine manufacturers or system manufacturers like plying machines or bending machines. So really all types of industries. Okay, somebody wanting to include their email, yes. All right, I think we've answered most of the questions, and it's 3:02. So if I haven't answered your question, feel free to send me an email. If you want a copy of the presentation, also please send me an email. I'll just respond with the slide deck as an attachment. So thank you everyone. Thank you for the good questions and the active participation. Thank you. Enjoy the rest of your day.
Yeah, thank you, Thomas, again for presenting today. We really appreciate your expert knowledge in this topic. We are going to send out a survey at the end of this presentation once it's all wrapped out. So if you have a moment, please, we would really appreciate if you fill that out for us. And we will see you all shortly. Thank you again, everyone. Bye.